project. So I'm not going to share any, I guess, slides deck. I'm just going to run through this interesting conversation of AI in production and what is the latest trends and conversations around systematically improving your AI projects. So I think everybody already heard about what is AI, and you know about the introductions and basics. I'm not going to talk too much about that. Essentially, if you think about just the difference between the AI versus the normal programming kind of coding that we used to kind of inject our own intuition into the code to deliver some sort of decision making. AI is more of automating that without direct, I guess, instruction. So think about AI algorithms like two pieces, the data side and the algorithm. Essentially, the algorithm will go through the data, understands the bits and pieces that we would like the algorithm to learn, and then we'll just make this intuition through the model and generate a model that will be used then to do the decision making. Let's just think about it. If you want to do a classification, the very obvious one is the cats and dogs. So you need to have a lot of images of cats and dogs labeled correctly, and the algorithm will just look at the image, understands the pixels, the colors, and the shapes in the image, and will correlate that with the label, and then we'll understand how to distinguish between these two particular labels. That's as easy as it is. The problem here is that the first part of it is the data, which we all know about it, that is very important. But data can be tricky. We all heard about the word garbage in, garbage out. I'm not going to talk about it too much, but essentially, if we look at the life cycle of AI, which I'm going to talk about right now, we can see that there is a little bit of misunderstanding about where we should focus in many cases. And there is an open discussion that maybe we should change our focus. So in the life cycle of AI, we have the first step, scoping, defining the project. This is obvious. We need to just talk about what do we want to do with this project, what is the approach, and what is the goal. And you need to have some understanding. Let's say, go back to our example. We want to use AI to machine learning algorithm, and I'm going to use AI and machine learning interchangeably. It's just because they're pretty much similar. I have a huge overlap, and I'm not in academia anymore, so I can just do this kind of not 100% accurate kind of definitions. But yeah, if you look at it in the more of a textbook definitions, AI is not 100% equal to machine learning. So let's just, for now, think about it the same. So in the scope of AI, we define the projects. We just say we want to use machine learning algorithm to understand the cats and dogs, and that's as easy as it is. So we need to get a lot of data labeled and put it into some, let's say, convolutional neural network, which is a baseline algorithm for kind of understanding and image classification. So that's the defining of the project, and you think about your tools, and let's say you want to use Azure cloud infrastructure and lots of other stuff that you need to think about to deliver your project in terms of tools and the processes. And you need to then define and collect the data. That's the most important part of any project. Like ETL, getting the data, making it, cleaning it, and making it right in the right format, right shape, and then storing it in a data set. I would say roughly 70-80% of the time is spent in this part. It's not fun. Let me tell you, if you haven't done it yet, I'm sure some of you have played with these algorithm or have done it professionally, but this is not the fun part. And I can see a lot of junior professionals and students who are doing internship. They probably will get to do a lot of these, and they're just going to be super unhappy about the experience. But the reality is, this is a very important step, and you are making an impact, a huge impact in the project. So think about it, about the impact and about what you will deliver to the next, next phase of these life cycle that needs to be very, very high quality. And yeah, it's already known, right? And if you've seen some of these examples of uncleaned data sets that just available on the internet, just one of them I've seen recently, it was very interesting. It was a long data set in US, and they had Philadelphia stored in like around 75 different ways. They're all misspelling and typos of Philadelphia. And imagine like somebody just going through the data set and finding all these different, different typos, identifying them, correcting them. It's just very time consuming. It's just something that you cannot expect. You don't know how people might misspell Philadelphia, and how difficult is it to, write the right way. You can argue also why in the first place they didn't have the right assurance to make sure that the data is collected in the right way. But anyway, that's the reality. You have the data, you need to deal with it. You need to go through a very, very laborious process to identify all these uncleaned kind of information and extract them, either get rid of them if you cannot transform it, or you need to just make sure you edit and make a correction. Also, there are lots of other examples. The Kaggle competitions, you will see a lot of data sets that have inaccuracies. And apart from all of this, also, if you think about the ethical frameworks and bias, they're also mostly related to the data set and the data that is collected. The reality is, we are, as a human, we are biased. And these bias will enter into the data, either a historical data, which has been collected through years and years, and it has the bias of the people of the time, or even the normal bias that are still fine. It can be about not giving a loan to a person that cannot afford to repay it, right? It is a bias. It's a good bias. It's a normal bias, but it is still part of it. So what is happening is that in this phase, you need to actually think about those ethical implications of your project, which I'm not going to go in deeper into this. It's a whole another conversation. It's like a very deep conversation. So just to let you know, I'm a member of ISO in the AI committee of ISO, and I'm like working on trustworthy AI and making standards in the world, and collaborating with different countries to make sure we make the best practices for the ethical AI. But what is happening is just it's not very easy, and actually acting and having a practical step is the most difficult part. Understanding it and talking about it is probably an easier thing to do. We know what is ethical in general, and we know what is not ethical in general. So that's not the difficult part. But getting back to our, life cycle. So you would identify these biases, you would take them out, and then your data is pretty much, I guess, ready for the next step. There's an interesting example about how data can change the thing. So a friend of mine was working on an image classification project, and he just tried to use some baseline algorithms, do a quick intuition, and run the data, like a pretty cleaned data through the pipeline. And he got around 70% accuracy of that multi-class classification, which is not too bad. It's pretty good. It cannot be probably used into any production because as a general rule of thumb, you need a little bit more, I guess, quality to put your machine learning algorithm in production. You need to make sure that you deliver value for your business, and roughly around 80-85% is what you're looking for in general. I mean, I can tell you that different cases are different, but that's just a general rule of thumb. But what is happening is just he wanted to have higher accuracy, so he spent a lot of time going through the state-of-art algorithm, this SOTAs, and trying to find these latest published papers, going through GitHub to find these algorithms and try to, first of all, understand, and then try to use the right data set and make it work together, which is actually very, very intense work, because it's just something that you need to do for probably a couple of different algorithms, and each one of them might have different requirements of the ETL and the deployment environment might be different. You need to Dockerize whatever it needs. But at the end of the day, after all the work, after all these painful steps, he just got 4% more accuracy. So 70 became 74. It is a great, I guess, outcome in terms of percentage. Still, we are far away. We are far away from something that would be acceptable in the industry. All right, so that's just a reality, and he just had to think about out of the box, like what should we do to make that work for us. And the next best thing that he could think about is just, all right, let's go one step back. I know we have done a lot of data cleaning, and we've done the major work that everybody would do through the process of getting rid of noises, anomalies, and all those different steps. But let's go back and have a look again. So through that kind of next step, he identified some extra noises, which you wouldn't actually find it as a noise if you just look at the data in a more of the normal fashion. It's just more of a misannotation of the image data and inconsistency between the annotation. So if you look at one image which is, let's say, annotated, the annotator just thought about the way to annotate this particular image was different from the other, annotator. And that's just the difference between two labeler, right? There's nothing wrong with any of them. So what is happening here is that I can tell you the difference between the way people think about annotating the data would make a huge impact into the database. Because after getting rid of those noise and making those similarly consistent, he got around 91% accuracy through that process. And interestingly, even the base model that he used got around 90% accuracy. So he didn't need to even go through the process of having state-of-the-art algorithm deployed and leveraged. He could have just done with the data. The other example is just the Kaggle competition. If you look at the Kaggle competition board, you would see most of the people are just having a bit of difference in terms of accuracy from each other. It's not even like, in some cases, it's not even 1%. It's just maybe 0.5% or even less. And they probably spent hours and hours and days and weeks of work to get another, I guess, 0.5% improvement. That doesn't actually, reflect when you deploy your model in your, business. You will not get the same outcome. Like that 0.5% will not have a huge impact in many cases. All right, if it is the critical, decision making that like it's either life and death, maybe that will be still a huge improvement. But in many cases, I guess that doesn't reflect in the same way, which means that you're essentially wasting a lot of your time playing with your data set and your algorithm, which is good to learn when you're doing a Kaggle competition. But in the real world, which is not just the learning, you need to deliver value, and your boss is just waiting for your model to be deployed. Maybe you want to do it differently, so you quickly deliver something that will bring some value back. And the other reason that a lot of people are not thinking about the data part of it is just because maybe it's just because of the researchers in the academia. They're just thinking too much about looking at the previous state-of-the-art algorithm that has been published a week ago and try to find a way to just improve it a little bit and publish another paper. That's just a cycle of a bit of improvement in the algorithm to just publish a paper, which is fine. It's great. It will help to push that side of the work forward in academia, but it would not be the best way to go forward for the business. So that's what I'm going to talk about the most, is just like think about it to have a different focus in terms of the way that you are using your time to deliver the AI algorithm. There are two other steps in your your project, your life cycle project, like training the model, which is probably the most interesting part for the junior professionals and the students. I know that most of my interns, when they join, they all expecting to start training the deep neural algorithms, like the deep learning algorithms, to to get some sort of magic happen, as of like it is a black box that will generate something extraordinary, and we need to get our hand as quick as possible to that model and feed the data to see what happens next. That's probably the general intuition of anybody who is joining a data science course or wants to be a data scientist in future. In their, I guess in their mind, they're mostly thinking about this part of the work as the most important part of it. And the error analysis, iterative improvement of the algorithm, that's just a normal step for the training the model. It is great. It is very, very important. Just to let you know, most of the companies are trying to kind of automate this part of the work. So don't think about it too much. I guess if you're thinking about joining the any companies in the next 4 or 5 years, that part of the work would have been probably mostly automated by some sort of auto ML or some sort of tools that will identify the best model, the best neural network architecture, and then hyperparameter tuning and all the tuning and regularization and whatever is needed to make that perform the best after you have your data ready. All right, so like Data Robot, I don't know, all these companies are thinking about it, and they're doing actively working. Some of the products is already out there. Some of them are a little bit expensive right now. We might get cheaper as we get more processing power and we get more, I guess, cheaper cloud platforms. So you need to have your, thinking pretty much in before the training. And what happens after the training? All right, deploying in production is the last step. So if you iterating again about the life cycle, it's just a scope and defining the project, and then defining and collecting the data, and then you will train the model and finally deploy it in production. A lot of people will just have a very, a good time and celebrating their achievement of deploying a model in production. It is great, still be happy about it, and that's a great achievement. Congratulations if you've done it, but that's not the end of it. I would say probably you have achieved around 70% of your work when you deploy your model into the prod. That's just the start. From there, you need to actively monitor and maintain your, algorithm and your model in the production. Because just think about it, like the users might change their, habits. The users might, the ecosystem might have a change, and there are lots of different things that might happen that you need to be aware of it. Just think about having the impact of COVID, right? People will change their habit. They will buy more online. They will buy more toilet papers, and that's what you need to understand as a model. So you need to collect the data and feed it back. So that's just maintaining the model in the right shape, getting the right data, putting it back is something that you need to be aware of. And that is called MLOps. Like literally, you need to understand right now what is MLOps, because that's going to be the way forward for all of us who are working in industry. It is essentially systematically making AI system work. That is like you can do the iterative, incremental kind of improvement in the way your model is working in production. And you need to flow the data back to understand the changes in the data and the way that users are working. And also you need to make sure that you're documenting and making the whole thing repeatable. And you have some processes like similar to software engineering life cycle. You have some sort of CI/CD kind of processes that will identify the defects and problems in each stage before putting your model into production and before making any changes, so nothing breaks. Going back to the data, so what should we do to make sure that the data is right? So you need to, in the same way, you need to have a systematic data quality assurance. You need to think about the ways that you can identify the defects and you can get rid of them. One of the ways is just like, let's go back to the same example of annotation. Let's say the data has been annotated by 2 or 3 or like 10 different annotators, labelers, right? I don't want to go into details, but I'm sure you all know that in most of the cases, you need to use labeled data to actually deliver some value to your business using machine learning algorithms. So it's a supervised learning. For doing that, many of the data that is available are not annotated properly, right? So if you just get images from the internet, those images are not all annotated properly, like let's say images of different animals, right? Some of the animals are actually very difficult to identify. They have a lot of similarities and very, it needs some sort of, I guess, some sort of expertise to identify the differences. And also the way that annotators or labelers would label these data are not always the same way, right? Each one of them by its own are great, can probably perform fine, but then putting it together, it's just the inconsistency will kind of push some noise into your data set, then it will affect your algorithm to understand it perfectly, and the model will be have a low accuracy. So what is happening, like there are different ways. You can have a voting system between the laborers, maybe have labeling the same data point a couple of times and see which vote is the best, or understanding the inconsistency between the votes is also important. Maybe there's a need to have instruction or best practices about the way to label the data set. And yeah, I guess the biggest challenge is essentially the smaller data set. So if you're working for Twitter or probably for Netflix, you would have less of this problem. But then if you're working for companies like startups and the other companies that have less amount of data, then a couple of low quality data points will have a huge impact in the final results. So maybe even just looking at the data manually would give you a better result than going through a complex, I guess, SOTA algorithms that will probably add lower improvement. So that's pretty much the takeaway that I would like to leave you with. And finally, I would like to wish you the success and great time participating in this hackathon. Hackathons are a great place for people to get to know each other, network, collaborate, learn from the mentors, and deliver something impactful, hopefully for the society. The least is just a learning journey and spending some great time among your friends and classmates. Thank you.
Thank you, Steve. And I've had the great pleasure of being on many hackathons with Steve, and cybersecurity ones and different ones. And Steve, would you like to tell the audience the number of followers you have on LinkedIn? It's quite remarkable.
Thank you, Jeff, for always supporting the projects and events. I just hit the 400,000 people on LinkedIn. It is absolute pleasure to be able to deliver some value on LinkedIn to the global audience. It seems that some of my audience are actually getting some value, and they're supporting it. So that's just a great outcome for me, and I will try to always improve the quality of the content that I'm sharing. I will have a lot of interesting announcements coming in the next week. Some discussions and interviews with the FANG, which is made of the companies like Facebook, Amazon, and let's say the big corporates, data scientists to learn about their journey, and some other interesting industry insights.